Hello again and welcome back. We are now on episode 6 of our web service design saga. Not bad. So this episode will be dedicated to glamorous things, international affairs. This episode will talk about what we have learned and what we have decided to do about developing applications which handle the challenges of everything international. So international is actually a word which breaks down into multiple consequences. We'll talk about all of them. And the impact of this internationalization in your software partly is on the server-side code, which is the web services, partly is on the front-end code. We will not talk about front-end, so let's talk about what happens in the server-side code. So we will go through the various aspects of internationalization in separate steps. The first thing to understand with what happens when you are operating in a multi-time zone scenario ecosystem is that all your servers need to agree on one common sort of alignment for timestamps in the database. So that becomes UTC. All server timestamps, all columns of type timestamp in your server need to be UTC. Okay, so that becomes uniform across your servers, across all your servers, even if you have servers in multiple data centers, wherever in the world they are, all timestamp columns in your database need to be UTC. All the timestamps, all the clocks running in the servers need to be set to UTC. And one of the things I am not going to get into right now is if you think UTC is GMT, then think again. There are fundamental differences, and I am very specific when I say that the timestamps need to be UTC and not GMT. There are times when UTC and GMT don't match. Web services must accept and return only UTC. This is very important to understand. So this is where the web service designer's role comes in. If the front-end code is calling a web service and specifying some timestamps as part of the parameters for that web service, that timestamp has to be in UTC. This means that when we split the application into front and back, we hide the details of time zones from the server-side code. UTC has web services have life simple. Web services don't need to know about time zones. They need to think only UTC. It is the front-end code or it is the client code which needs to know what local time zone is more appropriate for its work or for its human users, and it needs to convert UTC to local time zones in the front-end code, not within the web service. The one place where web services need to know time zones is for detailed reports. What's a detailed report? To be able to understand why, let us understand what is a detailed report and how it's different from a bunch of records. See, if I want to look at if I'm using an application and the application has a front end running in my browser and I'm looking at some transaction data. So I want to pull out some 20 transactions from the server. So my front end code makes a web service call and pulls out 100 transactions. Now, as far as the web service is concerned, all the timestamps in the transactions are UTC. But I am sitting, let us say, in Singapore, and I wish to look at those timestamps in the local context. So I am plus 0800, that is my timestamp offset from UTC. So when I want to apply the Singapore local time, the front-end code pulls out all the records from the server, converts all the UTC timestamps because it only has 100 records, right? It converts all the UTC timestamps to Singapore local time timestamps and displays them to me. That is how it's supposed to work. The one place where it fails is detailed reports. Why is that? If we look at the way typical large business applications generate detailed reports, they will be giving the reports either in the form of a CSV file or some other data file like a Excel spreadsheet which will have maybe 1 million records. Now, if this data dump with 1 million records comes to the front end, usually the front end does not process a detailed report at all. It either allows you to store it on your local hard disk, or it just displays it in a PDF or in Microsoft Excel or whatever. Therefore, the front end does not have much of an opportunity to patch the timestamps and convert them from UTC to local time. They can do it. The front end code can easily do it for 100 records. It can't do it for 1 million records. Therefore, only in that one case, we have a standard where we say that our standard solution to this problem is that all web services which generate detailed reports must take a end user timestamp as a parameter. So the offset between UTC and the desired end user timestamp must be supplied to the web service as a request parameter. And the web service must pull out the data from the server, patch all the UTC timestamps into the local time zone which has been asked for, and then generate the detailed report and give it back in CSV form or Excel spreadsheet form or any other form to the front end. So this is the one case where the web service is aware that there is such a thing called a time zone offset. Okay. Another interesting insight we have had by working with large applications and multi-time zone systems is that in financial transactions, there is something called an effective date, which is like a legal entity. So imagine that some transaction is happening in Singapore at 2 a.m. If I record it, let's say it's 2 a.m. on 10th of February. When I record it on my server is running UTC. Singapore is UTC plus 0800. So when I record it on the server will record it as 6 p.m. 9th February. 2 a.m. 10th February in Singapore is actually 6 p.m. 9th February in UTC, because there's an 8-hour difference. Now what happens then is there is a legal attribute of the date and time, the date on which a transaction happens. Now, if that date is pulled out by looking at the timestamp in UTC and just chopping off the hours and minutes, then you will be left with 9th February. Whereas legally, the transaction happened in its local venue, which was Singapore, on 10th February. So there is in these situations, just keeping the timestamp blindly in UTC is not good enough. You may also need to keep the effective date, may not be the effective timestamp, but effective date in the local time. So two fields may be required in your database table. One is the UTC timestamp, which gives you the exact timestamp precise to the second. And one is the effective date of the transaction, which is in the local time of the venue in which the transaction was effective. So the time at the venue where the transaction was effective, or the date at the venue where the transaction was effective, needs to be recorded separately. So this is a very interesting insight we learned, that the effective date has to be stored in the database separately. It's not enough to just store the UTC timestamp for a transaction where money value is involved and the effective date can have a legal bearing. So in those situations, we store the UTC timestamp in one column and the effective date in the local time of the venue where the transaction was effected in the second column. So we need to have both columns there. Something more about timestamps. The timestamps are a real pain because of time zones, and we don't really appreciate the challenge of the time zone mess very easily. See, we have said that all server timestamps must be in UTC, and we thought that we had beaten the time zone problem because we have brought everything down to a common denominator, which is the UTC timestamps. But that's not good enough. Look at this hypothetical situation, 5:30 p.m. on 31st March, 5 years from now. If somebody asks you what will be the UTC value for 5:30 p.m. 31st March, New York City, you can give it without any error. There is no ambiguity. There is no 5 ways to calculate 5 different values. The world will agree 5:30 p.m. 31st March in New York today is going to be UTC so and so. But what if it's 5 years from now? What will be the UTC offset of this local time 5 years, if this local time is for 31st March of the year 5 years from now? You cannot predict it, and let me explain why. Time zone definitions change. Go figure. Today we are saying that Nepal has a local time zone which is 5 hours 45 minutes ahead of UTC. Fine. Various things may happen between today and 5 years from now where Nepal decides that it is in Nepal's interests to shift it from 5:45 0545 to 0530 or 0600. So how will you predict today what will be the UTC value for a particular local time in Nepal local time 5 years from now? You don't know. The time zone definitions may change. The next thing that changes is daylight saving time starts and end dates. So today daylight saving time will be from one date to say some date in October to some date in February. 2 years from now, various decisions will be taken by various governments and other bodies, and it will be decided, no, we will not start daylight saving in October, we will start it in November. So if this change happens, then your offset calculation between the local time and UTC for a particular place 5 years from now is impossible to predict today. Therefore, you need to store, for future dates particularly, you need to store 4 values. You need to store the UTC timestamp as calculated based on time zone data and local time data of today. You also need to store the expected local time timestamp in that time zone, just to double check, so that if the UTC offset 5 years from now recalculated gives you a different figure, you know that it's the offset which has changed. The desirable outcome is the local time specified in the local time zone. Third thing you need to save is the time zone name or the time zone ID. Which time zone is this being applied to? And fourth is the TZ data version. I will not get into TZ data, but all Unix systems use time zone database called TZ data, and that is released in new versions whenever any time zone data anywhere in the world changes. So you need to specify all this and save the TZ data version so that later on when you want to recompute the local time from the UTC time, you can match the TZ data version available on your Unix systems at that time. Compare it with the TZ data version which was in vogue or in active state when the data was recorded and see if there is any change. If there is no change, you're fine. But if there is change, you have to recompute the UTC timestamp. So time zone data and internationalization of this local time to UTC problem is not trivial. The next area where internationalization will hit the web service designer is currency. All amounts must have a currency column together with the amount column. So wherever you're going to put a money amount, you have to also have another column called currency. That is fine. That is good. That is easy to understand. The next thing that you realize then is you cannot use SQL to arrive at totals of amounts because the amounts are not in the same currency. So you will need to either write a stored procedure to calculate the total amount or you have to do it in your code. So calculating sums and differences of two amounts is no longer trivial if the amounts are not in the same currency. So your code becomes more complex. The third thing that you need to worry about, and there your business rules and your business processes will come in, is do you need to store conversion data history? For instance, if I am generating a P&L and balance sheet for a particular company, then I will typically need to aggregate all the amounts in different currencies, convert them to one currency and report on an overall profit and loss or overall balance sheet value. How do I convert? I am getting the data of the last 5 years. How do I convert dollars to rupees or rupees to dollars or dollars to pounds for 5 years sitting today? Because the conversion rates have changed. Every day they change. So do I have to then convert each value by applying its conversion rate as was effective on that date? The answer sometimes is yes. So it's a really painful process. So conversion rate history data may need to be stored if you want to handle money amounts and multi-currency applications. Conversion to a single currency is not easy. It is not as simple as saying, what is the conversion rate? Plug it in, the formula is just a multiplier and you get an output. There are many challenges there. You need to decide, for instance, which conversion rate to pick up and the conversion rate of which date to pick up. If the transaction is effective on Wednesday, 25th March, do I pick up the conversion, the forex exchange rate which was in vogue on 25th March or 24th March, and so on and so forth. These are very important questions which the developer will find trivial and irritating, but the banker won't. So if you are developing financial processing software, then these questions can become real killers for currency conversion in your software. So internationalization of currency, not easy. And one of the things to remember is that currency is not connected to country. Just because I have my operations in one country and that country has one currency all over the country does not mean that the data inside my software system will all be in one currency. Because often you are recording transactions with overseas parties where the currency for the transaction or the currency for the agreement will be specified in the agreement itself, and so on and so forth. So just because the software is being used in one country doesn't mean that you can get away by hard coding one currency. The next point about internationalization is about formatting. If your web services are generating formatted data, you need to pay attention to formatting. If your web services are generating human readable data, numbers, human readable numerical data, you need to pay attention to formatting. So look at all these things which change from country to country. The currency symbol changes. The number formatting changes. We, in the countries that we operate in, are used to putting a comma after every 2 digits or 3 digits. In some countries, especially in many European countries, they put a space every 3 digits and they put a period to separate dollars from cents. They put a comma to separate dollars from cents. So if you're going to generate a detailed report in your web service and that detailed report will be passed on to somebody as an Excel spreadsheet, then he will be expecting to see data properly formatted. And if that formatting has to be generated in your web service, you need to know about the number formatting which is required at the other end. Then comes date formatting. How do you format for outputs? How do you format the date? Because different countries have different conventions for date and time formatting. And then there are various other challenges. Now, one of the things as a web service as a web service designer, you may need to take care of is users are using browsers sitting wherever they are sitting in different parts of the world, but the browser's local information, where the browser is located, that can come from various sources. So the web service may need to store a user's profile information where it specifies what the user's, let us say, location is. If the location is suppose the user is located in Singapore, but the user works for a company which operates out of Indonesia. So in many situations, the user can be located anywhere in the world, but the locale information will be decided by the organization of which the user is a member. So you need to take cognizance of these things in your design of the data structures for the user's locale profile. So these are things which may affect your web service ka code. Good, we are at the end of part 6. That's another episode over, and we will be looking forward to seeing you again at the beginning of part 7. In the meantime, have fun, knock yourself out writing web services.